Okay. Today's question is kind of fun for a con. Um, it's called Minecraft Mine, which is quite interesting. Okay, suppose that Steve in Minecraft is trapped in a dungeon and has a diamond pickaxe. There are three paths that he can take. Path one leads to his original position after 2 days. Path two leads to his original position after 4 days. And path three leads him to the surface after 8 days. So basically, there's two paths that are like go back to where you are after 2 or 4 days, and the path three is finally end and escapes. Steve selects doors completely at random and independently between selections. Let n be the number of times Steve must select the door before reaching safety, and t be the total amount of time for Steve to get out. Furthermore, let xi represent the amount of time that Steve takes to explore the path chosen at the ith term. Um, Let a of n equals the expected value of t given n equals n, and b of n is the expected value of sigma from technically it should be I, but it's a typo probably, but we understand that's from I to 1, I from 1 to n of xi. Find the limit as n goes to infinity of an divided by bn. If the limit doesn't exist, enter -1. Okay, so just a slight correction. The problem was not very correct here. This should have been either I or k. These should have been the same, but essentially we still get what it means. So how we're going to approach this question is kind of just break down what's being said, right? Path one is takes 2 days and leads back to failure with probability 1/3. 4 days with failure, probability 1/3. 8 days success with 1/3. If it's failure, then we're going back to our state. Success means we're ending it right off there, right? So it's an independent choice. So when we're trying to find the expected value of t given that n is equal to n, that means that Steve escapes on the nth turn. That's what we're given. So if he escapes on the nth turn, then that means that in the n-1 turn before that, he must have failed to escape. And then exactly on the nth turn, he escaped. So that means that on average, the expected fail turn would have either been 2 or 4. And then the average of that is 3 days because it's equally likely, right? And then on the last turn, he takes 8 days to escape. So what we have is we have expected value is 3 days for every failed term, which we have n-1 failed term. And then the last one we know it's a success, which takes 8 days. So in total, we have an is expected to be 3n plus 5. Pretty straightforward, I'd say, for an. Bn, there's a typo, yeah, here, because it should have been the same, consistent. But if it's independent, we kind of can just straight directly find a single turn. 1/3 of probability, that's 2. 1/3 of probability, that's 4. 1/3 of probability, that's 8. Plus it together, we get 14/3. So for n turns, we just do n times that amount would be our thing. So we're going to find the limit as n goes to infinity of this value of an divided by bn. So then it would just be 3n plus 5 divided by 14n divided by 3. So we kind of just work it out. We divide by n. As n goes to infinity, this 5 over n goes to 0. So then we have this. And then we just put the 3 up on top and we would get 9/14. And that would be our final answer. I think this question was quite fun. I'd say didn't expect Minecraft to show up in the quant questions, but I think it's a pleasant surprise. I think it's relatively easy as long as you understand what the terminology is asking for. The major thing is here that given n is equal to n, like we know that it took n turns. So we kind of logically deduce that the previous n-1 turns failed, and then the last one was a success. And then we can work it out from there. Okay, cool. Let's end it off here.